Hello everyone, welcome to our session. Before we deep dive into the details and nitty-gritties about the analysis, I just wanted to spend some time about who we are and what we do. So we are AP Moller Maersk. We are a global leader in shipping industry, operating in 130 plus countries, serving 100K plus customers. When most people think about Maersk, usually they think about ships and containers, but we are a technology-driven logistics company which is on its path of digital transformation, and we are connecting the global trade through APIs, data platforms, and related infrastructure. Now, when we talk about moving things from A to B, it is not only about the ships and ARLCL, but it also talks about various disparate systems which are interacting with each other, right? And when we talk about that, we have booking system, we have custom systems, we have inventory systems. There are a lot of systems which are interacting with each other via API to make one single customer booking successful, right? And in order to do that, we are leveraging the infrastructure at multiple places. Now, when we talk about APIs, as we all know, we are in the API first economy. So everything is almost driven by the APIs. And when we talk about that, it's not only about developing and onboarding the API, it is also about the complexities that keeps behind the scale, right? And it is just very easy because API is almost abstracts the complexities which is having. And when we talk about complexities, not only about the endpoints which we are exposing to the customers, it is also about API gateways, it is also about mesh infrastructure, and then we have a whole lot of backend applications which have its own details around it, dependencies and related things. So let's take a look at what does the complexity looks like at our end. Now, I would like to start off with a note that we are the brave ones who are on Kong open source stack, right? So whatever we are building, we are hosting it in-house. So what over here you are looking at is the runtime traffic which comes at our end. So what we have is all the traffic which is coming up from our customers, that comes to the Akamai, which is our edge DNS. Post that, wherein we are kind of handling the bot protection, WAF, and various other checks. Post that, the service is redirected to multiple Kong data planes based on the region affinity, right? So that's where request is routed to, wherein we are doing various validations. We have plugins for rate limiting, we have authentication, authorization, and various checks. Post that, we have Kuma service mesh, which takes care of service discovery. So it takes care of that. And then the request is redirected to either an external service or an internal service from there. So this is something looks like, and then we have various workloads running in different regions. Now, in order to, for gateway to route to service mesh, it needs to be service mesh aware. So we are running Kuma service mesh as a sidecar in our gateway containers. Now, in order to facilitate everything, because we are almost owning all the infrastructure, we have, and as you would have seen that we have Akamai, which to register a service, we have to take care of Akamai, we have to take care of data planes at Kuma, as well as API gateway. So we have developed a developer platform which takes care of all these complexities, so that our developers at Maersk can focus on building solutions for business and rest leaving the infrastructure related things at our side. So while the platform allows us to ship software faster, operating them at a Maersk scale it's a different beast, because we are talking about multiple systems working in tandem to have a flow successful at Maersk. Now, in order to talk about the operational challenges what we face in this whole ecosystem which we have built, I would like to invite my colleague Abhishek to take through.
Yeah. So as we now are aware what is the infrastructure and how the runtime traffic flow, let's look at our setup in terms of operational challenges. So we have got around 3,500 developers managing 1,500 APIs across Maersk, and on them around 4,000 plus and counting consumers depend 24/7. And at this scale, the question is not about if things gonna fail. It's about what will happen when things fail. How prepared are we? Do we have a robust incident management protocol? firefighting SOPs and stuff. Even having those doesn't solve the problem. You need to detect the incident before it bubbles more. So that's where MTTD comes into picture, how early we can detect. It's pure game of visibility metrics, and that's where no AI can help you. It's pure instrumentation. Then once you detect the fault, then how quickly can we resolve it? That's where the organizations depend on skilled engineer, always available with their laptop 24/7 on call. And that's not a great place to be from a developer standpoint and from an organization standpoint, because incidents don't occur during your operational hours or office hours. And last but not least, understanding the scale of an impact, the blast radius of it. This is very crucial from business standpoint because they want to know if they are bleeding dollars or are they breaching SLAs. And if we sum it up all, we know all these challenges are mostly faced by SREs and dev teams. And a couple of months back when we were evaluating our challenges, this was one of the hot topics, like how can we reduce our friction during on-call incidents? And that's the reality of most of the developers. I would like, if you guys relate to this image, please raise your hand if you have ever been in this situation. Yes, that resonates with most of the engineers across organization and industry. So, and we being part of the API ecosystem of Maersk, so we get pulled into every incident bridge, no matter where the fault is. And we have realized, like multiple instances, the gateway is not at the fault. The fault could be somewhere down in the application layers. And that creates a lot of, the MTTD rises quite a lot because most of the time when an incident occurs, you have got command center who pulls in a lot of streams, and then you have question answer, okay, fine, what is breaking, where are the logs? It usually takes 15 to 20 minutes to even identify the fault itself. And that's where we have identified, like, can we build an agent which can do this first level of triage or become our first responder itself? And yes, so that's where we build Stargate AI agent. So without even giving much in description, so what I'll try to do is demonstrate it in live. So we'll simulate an incident and see how the agent behaves. So what I'll show you is, this is our developer platform, what we are seeing over here. How do we take the mouse over there? This is really tough. Okay, so this is our developer platform. And this is the application which is hosting an API on this path, Stargate/Expedition. And for this demo purpose, I have purposely deactivated this backend. So this is simulating a scenario where the backend is not available right now. And there would be clients which would be trying to consume this API. So I'll just fetch so as expected, now we are getting a 503 suggesting that something is wrong. But from a client's lens, we don't know actually the fault is at the gateway or somewhere down the stream. And that is the same scenario for an incident as well. They are clueless what's going on. So what we'll do is we'll fire a few of the requests, and the moment this API was also onboarded, we have also automated the configuration of alerts and matrices on this as standard procedures. So what will happen is eventually it will breach the threshold and it will trigger alerts. And in normal scenario, what will happen, should happen is all the respective teams should get the alert and then take actions, or the incident bridge calls up over pager duty or other stuff. But in our scenario, we have this agent, so the expectation is the agent should react to this event and help us understand what the fault is. So we'll just quickly take a look what's happening on the monitoring side of the world. Are we, okay, so this is the alert which we were configured automatically whenever the API was registered for the first time. Yeah, so right now it is in pending state in 17 days, so it should just fire in 1 second of a window. Yeah, so right now it is in firing state. So let's take a look what's happening on the messaging front. So this is the first alert, which is a standard Grafana alert, which just sends a bunch of details about what went wrong. But the next message is where the agent has summarized it and given a hypothesis of what has happened over here. So there are a few useful links like the proxy ID, which is the issue. So right now, most of the cases, what happens, people know exactly booking API is not working. They know exactly the path. They don't know what's the API behind it. So the first thing is identifying the proxy ID, then alert link, proxy gateway links. So even if you know in the incident bridge before the gateway team joins in, the other people's no clue how to figure out the gateway access logs. So it also furnishes the gateway access logs, the application link, and then it has a hypothesis. Let's look at what it suggests to say. So the dominant error across logs is a name resolution failed, which is exactly what the errors we are seeing. It has failed, the request failed showed target time equals to 0. This is a custom attribute in the log, which understands the request never made it to the backend service, meaning no request reached the backend service, failure occurring on the gateway due to DNS service discovery. Health check status is unhealthy. Now, the agent did not only check the logs, it also went to check the application health in the backend and has identified the application which is unhealthy, which exactly confirms the fact as we have disabled the application. No authentication or security issues have been identified. So it also gives these informations. It has also done a blast radius analysis, identifying this proxy was being consumed by 3 consumers and they may have been impacted with this. So now, with this information in hand, I can just confidently join the bridge call. And in this scenario, actually the problem is not on the gateway, so nothing needs to be done from our end. And this just happened in a matter of seconds, for which previously it used to happen over a 20 minutes bridge call. So let's take a look like how it is able to achieve this. Yeah, so this is the agent's workflow over here. So the first step is detection. It detects through webhook events. So the agent listens to Grafana alerts on a webhook endpoint. Whenever it detects, then it starts the RCA process. The next thing is gathering metadata. So as Manish has shown the developer platform, that's the foundational basis. With the help of these foundational layers, the agent actually talks to all our services and fetches all these metadata about what's the proxy name, what is the backend application, and stuff, ownership and those criticality, other stuff as well. Then the next step is analyze log. We'll dive deeper into it, how we are analyzing the logs. Then analyzing the application health as well. This is also with the platform capabilities, we able to understand the application health by checking the service mesh health checks. Then last thing is pretty straightforward, clubbing all these data points and then generating a hypothesis out of it. And then notifying. Right now it is notifying to our channel, but the idea is in future it would actually pinpoint exact ownership. If the fault is on the application level, it should just notify to the application owner itself. This is the architecture. Right now it is self-explanatory. It's pretty simple. So we have got an event listener, which is a webhook path, which listens to our observability platform. Once an event is triggered, we have an orchestrator function, which actually orchestrates 2 different agents and has got functions to talk to metadata service and health probes. And gathering these 2 data points, it actually talks to, orchestrates 2 different agents. One of the agent has a function, log extractor tool, which talks to our monitoring platform to fetch logs and stuff. And once all of these are done, it has a notifier, which actually publishes notification over Teams right now. So we can also dive into the code a bit to see how these agents are written. So this is a simple Python fast API server, which has a webhook endpoint. Wait a minute. Yeah, a simple webhook alert seems like this. Once a webhook is received over this path, we start the RCA. The first step is to identify the impact analysis, where we are fetching the consumers, how many consumers this proxy was consumed. So this function actually calls our platform APIs, which internally talks to Kong's admin APIs to fetch consumers which this proxy was registered with. Next is identifying the application health. This is where also we are using our platform APIs to identify the health status of the backend application powering the API. Once these 2 steps are achieved, then the next step is to analyze the logs. This is where we are using agent to do so. We'll take a look at this agent, analyzer agent. So this uses a ChatGPT 4.0 Azure hosted model. And it has a function tool called fetch mag proxy logs. So this is the function which is responsible to fetch logs from our monitoring platform. And then it's not straightforward like you fetch the logs and pass it to the agent, because your logs might have sensitive information and it may be too bloated. So there needs to be some pre-processing done on that logs. So this is where we are extracting certain features. A typical log line, if I would show you of, wait a minute. Yeah, so this is a typical log line which has got 80 plus attributes, and some of them are standard attributes, some of them are custom, which we inject before publishing it to the monitoring platform. So, and you don't need all of them to be analyzed. You may need only few of them. This is where we are doing a feature extraction where we pinpoint and extract very specific attributes like timestamp, trace IDs, status codes, paths, and some of the custom attributes like total request time, total proxy time, and total target time. Target time is the time which it spends on the backend application. Proxy time, the request, how much it spends on the gateway itself. And the total request time is the total turnaround time. These are for performance analysis and also to identify where the request failed. Did it fail on the gateway or on the backend application? So once we have extracted these information, it does two things: feature extraction and also eliminating the sensitive informations like keys, IP addresses, and other sensitive informations. So once this is done, we pass it on to the agent, but just passing the entire logs also may not make sense because some of the attributes are custom attributes. We have to explain the agent what each and every attribute mean and how it needs to be interpreted while doing analysis. And that's where I would like to draw your attention to this line. So if we take a look at this analysis requirement, so we are explaining what total target time is and how it needs to be interpreted. If total target time is 0, the request did not reach the target service. And based on these feedbacks, the agent is able to pinpoint exact the way we would interpret our logs. And it generates the log output in a formatted fashion so that it is well enough programmatically we can extract each and every attribute and then process it. And once the output is received, we pass the same data to the RC agent. This is another agent which is only responsible of joining the dots. So now we take the log analysis output, health check metadata, and then pass it on to the RCA agent to come up with a hypothesis about what could be the possible reason behind the failure. So if we take a look at this agent, so the instructions are pretty simple. This is something which I would like to draw your attention. Here we are using a few shot learning where we are passing certain examples and the output which is correct. So taking the first example, if we are suggesting if the service health is unhealthy, there are multiple 503 errors, then in the logs, and then the backend applications are not healthy or the microservice is unavailable. No fault on the gateway as the DNS configuration was validated at the time of registering because the bot may interpret like the configuration is wrong. So these kind of feedback loops, few short learnings helps the bot to, or the agent to identify, pinpoint the exact fault. And with that, the RCA output is generated and then the notification is sent over the team channel. Yeah, so with that, I would just try to sum it up about our key learnings from building this agent. Yeah, so I can't stress upon agent is as good as its integrations because as I have shown, the agents are pretty simple in terms of the function or their capabilities. The only essence is all about the integrations and the APIs which they have access to. So the path forward is also to hook up to some other APIs which will allow this agent to take necessary proactive actions to mitigate this in terms of if certain data plane is down, can it just remove it from the load balancer so that we can shift the traffic to the other healthy region of the gateway. Such kind of mitigation actions can be configured by integrating with the APIs. The other is help agents to understand your data. That's where we have shown how we explain each and every attribute of the custom attributes of the logs to help the agent understand how to interpret them. And yeah, a few short learning, though it seems very simple in terms of, okay, we are just suggesting example, but it actually takes your agent response from a 50% accuracy to 80% accuracy. That's where the game is. Yeah, that was all from my end. I'll open up for questions. Thank you.
Thank you very much.
Yeah.
We've got a couple of minutes for questions, so.
Hi there. Quick question on your trigger that triggers this whole analysis. Is that governed from Grafana? So when we were waiting there, looking, waiting for your Grafana thing to kind of detect the anomaly.
Okay, so you're talking about the webhook integration.
Yes, yeah. Is that configured in Grafana itself?
Yeah, yeah. So whenever this platform itself, whenever we onboard any API, wait a second. Yeah, so the Stargate control plane is our API management platform. So whenever we onboard any API onto it, we make sure we onboard it to gateway, configure necessary stuff in service mesh, Akamai, and also configure alerting rules on the observability platform, which is Grafana and Prometheus.
Yeah. So my question specifically, what's like to avoid getting kind of false positives?
Oh yeah.
What's going to be your sort of tolerance? What's your threshold? Because you're not going to just the first,
Yes,
503. Where
yeah, absolutely. That's a real problem. So right now we have given this responsibility to the API owners instead of we owning it. So you decide what should be your alert criteria, what should be your P1 criteria, what should be your P2 criteria. In what case you want a RCA to be done, in what case you just want a team notification and just be aware of it. Okay, fine, we'll see. So that's the model we have going forward. But essentially what we are looking at is to derive these metrics out of the traffic, and can we identify what should be the P1 criteria for API fault.
Yeah. Are you done?
Yep.
You're done?
Yeah, he's done.
Yeah, fine. Thanks. It was a nice presentation. So my question here is, you talked about the Teams channel notifications,
Yes.
right? So you are planning to enhance the Teams channel notifications to the people whose,
Yes.
how are you going to identify them?
Okay.
Is it with the upstreams?
No, the idea is, so we have, our developer platform has got multiple capabilities, and we have shown few of them. So there is one called, which actually is a culmination of PagerDuty and some other tools, which handles our on-call schedules. So the idea is whenever we are triggering a notification, the agent should talk to this service, which is our we call it Hedwig, to identify which are the teams channel to be notified based on this scenario. And then from that, we would just call that Hedwig service API, and it will take care of notifying it over email or messaging, because those things are configured by the team itself on Hedwig platform.
Okay, so you have an incident management platform where you...
Yeah.
Okay, nice.
It's an on-call scheduling, sort of a PagerDuty thing.
Okay, time for just one last question down the back here, and then we'll break for lunch.
Is your agent able to distinguish between the gateway and then the mesh and then the backend? If there's issues, it knows like, oh, it's probably the gateway or the mesh or the backend.
Yeah, absolutely. So as I have shown in the, wait a second. Yeah, so this attribute called total target time, this indicates how much time the request has spent on the backend application. So this is a log attribute which can be seen. If it is 0, it suggests the request was dropped at the gateway itself. So the next thing to check is, since the issue is not at the gateway, look at the backend application. The next thing which can be enhanced over here is to also identify fault of the gateway. So let's say there are multiple policies which are getting evaluated at Kong. Did any policy failure was there? But that can be also identified by understanding error message. Since the error message suggests it is 503 unavailable, service unavailable, it is a very specific to Kong Kuma service mesh error, with which we are able to identify it as a service mesh issue. Let's do a health check on the service endpoint, and we use our data planes to talk to service mesh health check status, and then we identify what is the status of the health.
Okay, fantastic. Thank you very much, Manish and Abhishek.